All right, this is Algebra 2, Lesson 13.2, General Angles and Radian Measure. We're talking about measuring angles in standard position using degree and radian measure. And then we're talking about calculating arc lengths and areas of sectors, beginning on page 776 in our textbook. We have 6 definitions to start. The first one is an initial side and a terminal side. An angle can be generated by fixing one ray. You don't use the term ray a whole lot in math, but it's something that you learned early on, and it was refreshed for you when you did geometry. Remember, a ray, all it is a point and a line. So it's a line that stops or begins at one point, its initial point, and then extends infinitely. That's what a ray is. Um, Fixing one ray called the initial side. So where you start at is the initial part. That's easy to remember and understand. And then rotating the other ray. So from there, if you have another ray that opens up, like say this ray, again, starting at a point and going on infinitely, that ray opens up. You can think of two hands on a clock, talking about your initial and your terminal side. Um, and it's rotating about the vertex, and the vertex is simply the point where they both begin. If something is in standard position, that means that it begins on the positive y-axis. So standard position is easy to comprehend. Think of a plane. This is the easiest way to think of standard position. Standard position, the initial ray always begins right here. It always begins on the positive x-axis, so just like that. It's in standard position if it begins right there, regardless of which way it rotates. So it could rotate going this way all the way to here, for example, and look like this. Now we know that that's greater than 180 degrees. Or it could rotate going the other way. It can go, let's say, to here and have yourself a ray going that way. But again, that's considered standard position no matter how many times, no matter how many revolutions you have or how many times it goes around, as long as it begins on a positive x-axis and it opens up either positively going counterclockwise or negatively going clockwise. Two angles are coterminal when their terminal sides coincide. That's that's a confusing definition for what coterminal means. This is all coterminal means. This means like this angle, let's say it starts here in standard position. I know it's supposed to be on the x-axis. I just rose it up a little bit where you can see it. This angle looks like this, and this angle starts on the same position, but it goes like this. Let's say it rotates this way. Those are coterminal, the blue one and the red one, because they both start in standard position. The blue one opens up counterclockwise. The red one opens up clockwise, but they finish or they have their terminal side in the same position. Those are considered coterminal. So what do you know, just real roughly and real quickly, what do you know based on what I have drawn up here? If you put these two angles together, the blue one and the red one, what will they equal up to? If you put the two degree measurements together, it's got to be 360 because they're going to be 360 degrees. Now, where people get confused with coterminal angles is you said 360 just now, which is absolutely right. But what happens if they had more than one revolution? That's where it starts confusing students. If it goes, instead of just going around once, it goes around twice. Don't let it confuse you. I'm going to show you an easy way to do it in just a minute. A radian in a circle with radius r and center at the origin, so it's talking about at 0, 0. Remember, that's what origin means. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. Again, that's a fancy definition. A radian is simply talking about the distance, the round distance, when radian is considered to be 1. When the radius itself is considered to be 1. Because all angles, when you're talking about them in standard position, no matter how big they are or how long the radius is, all you have to do is use the same formula and you just change that one number and it makes it all fit. But the radian, again, is talking about the distance around something. A region of a circle that is bounded by two radii and an arc of the circle. Again, think of a sector. If you're talking about the area of a circle, you know you have to know what the radius is. The area of the whole circle is pi times radius squared. That's a formula we've been using for a long time. That's of a whole circle. A sector is just that one piece of the pie. So if you wanted to just find what the area of that piece of the pie is, or that slice of pizza. So think of a sector as a slice of pizza. It won't always be cut perfect. It won't always be 90 degrees. It'll be different degrees, but you can find it the same way, and I'll show you how to do that. A central angle is an angle formed by two radii of a circle. So central angle, just talking about from the center or from the origin to each radius forms something called a central angle. It may or may not be in standard position. Example number one is drawing an angle in standard position. So the directions say draw an angle with a measure of negative 80 degrees in standard position. Then tell which quadrant the terminal side lies. Now, here's something to know real quick. If the degree measurement is positive, write this underneath this. If it's positive, it goes counterclockwise. Counterclockwise. If it is negative, it goes clockwise. So if it starts in standard position, that means it's starting on the x-axis. And it said the terminal side is 80 degrees clockwise. Notice right here it says negative 80 degrees, and then here it just says 80 degrees. Because all the negative part of that tells you is that instead of going counterclockwise, instead of opening up this way, it's going to open up going down the other way. That's all it's telling you, down or counterclockwise. So it's going to open up down. You know that if it opened all the way up to the y-axis, it would be 90 degrees. So you know just a little bit short of 90 degrees is 80 degrees. You can estimate when you draw that in. Doesn't have to be perfect. And then it just asks which quadrant is it in. If you forgot your quadrants, remember it starts here. This is quadrant 1. This is 2. This is 3. And the reason they're listed as 1, 2, 3, 4 this way in this order is because when something opens positively, it goes up. So that's quadrant 1 it starts in, then it goes to 2, down to 3, and then over to 4. This one, since it's going clockwise negative, it just goes immediately to quadrant 4. So on the back or on the side, wherever you got some space. Draw an angle. You don't have to write all them words and everything, but draw an angle with the given measure in standard position. Then tell which quadrant the terminal side lies. Take about 25 seconds on that. If you're having problems starting, start like this. You know your initial one's going to be here. Okay, we know it's negative 120 degrees. So that negative, all it tells us is either counterclockwise or clockwise. Remember a second ago we wrote that if it's negative, you're going to go clockwise. So the same way a clock goes, which is going to be this way, it's going to go like this. The same way a clock goes, that's the way we want to go. We want to go 120 degrees. You know that if you open up all of this, that's 180 degrees because it gives you a straight line. So you know you're not going to go that far. You know if you only open up this much, it's going to be 90 degrees. So you know you got to go past that. You got to go 30 degrees past that, not quite 45 degrees. So again, it's going to be kind of an estimate, but right around here somewhere, if it opened up, and draw this little arrow to go with it, showing that that's the way you went. That's what negative 120 degrees would look like. And then it just simply asks which quadrant that is, and we know that that's quadrant number 3, and listed as Roman numerals. Just the way we keep it consistent with how we've always done quadrants. Do this one too. What about 400 degrees? Again, remember, you can make more than one revolution. Think about what happens. You draw the revolution to where you can see it, and you'll realize just how not hard it is. Okay, the first thing you got to notice is that it's positive. You know, positive angle measurements are going to open up counterclockwise. Again, you're going to start here. You're going to open up counterclockwise. You know that this is greater than 360 degrees. So you're going to make a revolution all the way around. So we got to 360. You know you got to go 40 degrees past 360. So we have to go past that about to this point right here. So that's what your angle should look like, all the way around plus 40 degrees. And we know that it's going to be in quadrant number 1. So again, all you need to know, positive or negative, which way does it open? And you can make as many revolutions as possible to get to the degree measurement necessary. Example number 2 is finding coterminal angles. You know what that prefix co means? It means together. It says find one positive and one negative angle coterminal with 145 degrees and negative 395 degrees. So a positive coterminal angle, think about what's going on. The first one, if it's 145 degrees, it's going to be kind of right here. So a positive one would mean that you got to go the same direction. So how can I open the same way and get to this without naming the same angle? Without naming 145 degrees, what would I do? I would go around again. And that's why it's 145 plus 360. What about for a negative one? What if we go negative? What if we open here and we go this way? How would we find that measurement? Instead of adding 360 to it like we did for the first one, you simply subtract 360. So, and this goes back to what we looked at on the bell work. So 145 minus 360 is negative 215. Now the next one is a little bit confusing. It says find a positive and negative of this one. Negative 395 degrees. And again, since we go on negative 395, you know you're going to open up 360, and then you got to go 35 more to right there. So that angle is going to be there. It's positive coterminal. They listed 2 revolutions. You could have started here and simply gone around to this one. But they list 2 times 360, which is totally fine. Just going around twice gives you 325 degrees. And the negative one is if you go the same way. So you got to go twice this way. You start here, you go around to it, and then you go around again. That's why it's negative 755. This is the part that is confusing the students. Remember, coterminal angles are not set how many times you got to go around. You can go around as many times as necessary. And we'll look at the rest of it tomorrow.